Okay, so this is the paper 1 higher tier gap analysis paper. Right, find the highest common factor of 36 and 90. So on this question we need to be doing a product of primes to start with. So you can either start dividing by 2, or you could say, well, I know that this is 4 times 9, so that's 2 and 2, 3 and 3. 90, 9 times 10, so 3 and 3, 2 and 5. And on these questions I always circle my prime factors to make sure that I don't mix them up with my other numbers. In my long marking career, it's most effective when we have numbers put in a Venn diagram. So firstly I'm going to pair things up. So I've got a 2 and a 2 that I can pair up and go in the middle. A 3 and a 3 I can pair up, go in the middle. A 3 and 3 pair up and go in the middle. Then nothing else can pair up, so I'm going to put a 5 over here and a 2 in there. Highest common factor is everything in the middle multiplied together, so it's 2 times 3 times 3. So 3 times 3 is 9, times 2 is 18. Question number 2. There are only red counters, white counters, blue, green in a bag. So instantly, and this coupled with this table, I can see this is going to be a probability question, and I know my probabilities always add to 1, so that's going to be helpful. So notice I'm doing this before I've read the rest of the question. I can see 0.4 plus 0.3 is 0.7, which must mean that these two add together to be 0.3. Jo is going to take at random a counter from the bag. The table shows the probability she will take a red and the probability she will take a white. Fine, done that. There are twice as many green as there are blue. So green and blue. Green, there are twice as many as there are blue. So it doesn't really matter how many are in here, I'm just kind of visualising that there are 2 times as many green as blue. And I know that these two add up to be 0.3, because that's what's missing. So it's quite clear to me now that each of those is just going to be 0.1. I've got 0.1, 0.1, 0.1. Before I get carried away, I'm going to put these numbers into my table. So blue is 0.1, green is 0.2. Work out the probability Jo will take a green counter. Well, there it is, 0.2. There are 15 white counters in the bag. Work out the total numbers of counters in the bag. Well, 15 white counters is represented by a probability of 0.3. So that's my probability and that's my number of counters. Well, probably easiest for me to work out what 0.1 is worth, because I'm going to use some kind of scaling here. So divide by 3, so I'm going to divide that by 3, which is 5. And that's 10% or 0.1 or 1/10, and I need the full 1. So what do I do to turn from here to here? I'm going to times by 10, so I times by 10, I'm going to get 50. And there it is, total number of counters in the bag is 50. Okay, a delivery company has a total of 240 cars and vans. The number of cars, the number of vans is 7 to 3. I'm going to pause before I read anything else, and I'm going to do something with this information. So 7 to 3 is cars to vans, and that is a total of 10 parts. Well, I've got 240, so 240, that's times by 24 to get from there to there. So I'm going to times each of these by 24. I'm not going to lie, I'm going to cheat, speed us up. So 3 times 24, oh, perhaps it's on, 3 times 24, 72, and 7 times 24 is 168. So now I'm going to tick off that I've used that information. Each car and each van uses electricity, diesel or petrol. 3/8 of means to multiply in maths, the vans use electricity. So how many vans have I got? I've got 72, and I now know that 3/8 of the 72 use electricity. You can write it like this and then times it like that, times fractions together, or you can literally do 72 divided by 8 and times by 3. So I'm thinking most people will do that. 72 divided by 8 is 9. 9 times 3 is 27. So this means that 3/8 of van use electricity. So electric vans, in fact I'll write it down here. electric fans is 27. It says 25%, I'm going to tick that off actually, 25% of the vans use diesel. So we're still on vans, 25% of them use diesel. I'll use a different colour. So 25% is a quarter. A quarter of the vans use diesel. Quarter of 72, I'll do this one the other way. So I'm going to multiply these fractions together. They're both divisible by 2, that's my easiest way to start with. These are both divisible by 2, 1 and 18. So this must mean 1 times 18, 1 times 1. 18 are diesel vans. The rest of, I've used that, take it off. The rest of the vans use petrol, so I'm going to pause. I've got 27 and 18. So 72 minus 27 minus 18. Again, I'm going to cheat for in the essence of time. 27. So 27 of the vans use petrol. So they're petrol vans. Work out the number of vans that use petrol. Oh, there it is, 27. So I didn't even read the question, but I got there in the end. Okay, question number 4. There are 180 chocolates in a box. There are only dark, milk and white. 1/6 of, there's that of coming up again, 1/6 of the 180 chocolates are dark chocolate. So I'm going to start with that. I'm going to do something with that. So I'm going to do 1/6 of 180, which is the same as doing 180 divided by 6. 180 divided by 6 is 30. So that means that there are 30 dark chocolates. I'm going to tick that off, and actually I'm going to, before I go on, I'm going to say, well, if there's 180 in the box, 180 minus 30 is 150. So there are 150 left, and those must be the milk and white. The number of milk chocolates, the number of white chocolates, so milk to white is 1 to 2. Well, that adds up to 3 parts. And we actually have already done a small calculation here, because we've said, well, I know there's 150 left. So, times by 50, times by 50, times by 50. So, there are 50 milk and 100 white. Tick it off, I've used that bit of information. The number of white to dark, I'm going to pause for a second. White to dark. I'm going to go through and find, there's my dark, there's my white. White to dark is in the ratio 1 to n. 1 to n. I need to know, work out the value of n. Well, from there to there is divide by 100. So from there to there, divide by 100. 30 divided by 100 is 0.3 or 0.30. 10 milk chocolates from the box are eaten. Does this affect your answer to part 8? Well, if I've eaten 10 milk chocolates, then no, since we still have 100 white and 30 dark, i.e. they have not changed. So the number of white and dark have not changed. Right, next question. Work out 6.8 times 10 to the 3. I'm going to pause for a second. That is 6.8 times 10 to the 3, 1, 2, 3, yeah, 6,800. And 4.5 times 10 to the 2. Well, 10 to the 2 is the same as times by 100, isn't it? 10 squared is 100. That would be the same as times by 1,000. So we need to add 4.5, 1, 2, 450. Just double check that my decimal point is there, times by 10 times by 10. I'm going to add them together. 6,800 plus 450. 0, 5, 2, 1, 7, 250. Give your answer in standard form. Well, that's going to be 7.25 times 10 to the power of. My decimal point is here. How many times am I having to bounce my decimal point? 1, 2, 3. It's the same as timesing by 1,000, which is 10 to the power of 3. Okay, question number 6. 4 sides of a regular polygon with n sides. We don't know how many sides this has. BXC is a right-angled isosceles triangle. Here it is, right-angled isosceles triangle. Isosceles means that these two angles must be the same. So before I do anything else, I'm going to do 180 minus 90. I'm going to take that away and I'm going to share that across those two angles. That's 45 degrees. Each of those is 45 degrees. So I've used that bit of information. CDYX is a rectangle. So here's my rectangle. That must be 90 degrees in here, which means my whole thing is, my whole interior angle is 135 degrees. I've used this bit of information. Before I read on, I'm going to make a note of what my exterior angle is. My exterior comes up here. My exterior, it's not the whole thing around, it's just that little bit. So when you extend one of the sides out along the straight line, my exterior is going to be 180 minus 135. So my exterior is going to be 45 degrees. All exterior angles, the whole way around, if I just keep going round like this, just keep coming, they all add up to 360. So if I now do 360 divided by 45, it will tell me how many sides there are. If you're not confident with doing this sort of thing, I can see that both 360 and 45, or 36 and 45, are divisible by 9. So I'm going to start with that. 36 divided by 9 is 4. 45 divided by 9 is 5. So I'm now looking at doing 40 divided by 5, which is a much easier calculation. Give me 8. Question 7, simplify. This is the same as saying 3 minus p times 3 minus p, it's squared. If I write it like this, on the bottom here I've got a 3 minus p, so I can cancel out, and I'm just left with 4 lots of 3 minus p. Obviously you can expand that if you wanted to get 12 minus 4p. If you expand it incorrectly though, you will lose the mark. So to my mind, you may as well just leave it like that. Question part B. Safest way I've seen for doing this is to move or add 12 to both sides first. So I've got 8 plus x plus 12 is equal to 7x over 2. I am going to simplify that. So I've got x plus 20 greater than or equal to 7x over 2. Now I'm going to multiply through by 2. So what people were doing in the exams, they were multiplying through by 2, for example, and forgetting to multiply this number by 2. So I've got 2 lots of x plus 20 greater than or equal to 7x. Expand my bracket. Take 2x off both sides. Divide, I'm going to go up here to run out of space. Divide through by 5. And notice how I'm leaving my x on the right hand side. It doesn't matter that it's there. 40 divided by 5 is 8. And there is my answer. Done. Something to note is that just putting, for example, plus 12 plus 12, writing that underneath there is not a method mark. If you then make an arithmetic error to the next line, you are not going to get the method marks. Right, question C here. This is the same as sort of thinking about it like having two equal signs, if you like. I am going to take 5 off everything. I have to take 5 off there, and off there. So as I was just saying in terms of method marks, writing 11 minus 5, if you want to write this, you can. You are taking off 5. This is now a method mark. It looks a bit messy, but that's a method mark. 11 minus 5 is obviously 6. Plus 5 minus 5 has gone away. That's the whole point of what we were just doing. It becomes 0. And 16 minus 5 is 11. Now I need to divide through everything by 2. So I've got 6 over 2 and 11 over 2. Well, 6 over 2 is 3, isn't it? Why? 11 over 2. Nowhere on here does it mention anything about integer values, so don't be doing that. Right, moving on. Question 8. ABC is a right-angled triangle. It's the big one here. Before I start, I can see a triangle within a triangle, so personally I would redraw that as the big triangle and the small triangle. That's 28 and 40. That is 30. It does say it's right-angled. AEB and ADC are straight lines parallel to. So parallel, when I see the word parallel, I'm thinking corresponding, alternate, and co-interior. Okay, prove that triangle ABC is similar to. So when we're talking about similar, we're not talking about finding side, angle, side, RHS, things like that. We're talking about showing that all angles are the same. So I know that these two angles are the same because of corresponding angles. So I'm going to say that angle ADE is equal to ACB because corresponding angles are equal. Being a bit shortcutted there, corresponding angles are equal. So I've got one set of angles that's the same. This angle up here is actually the same in both, isn't it? So we can say that angle A, or DAE, is equal to CAB. It's a shared angle. You can then say that angle AED, which we know they told us it's most likely that's the right angle, is the same as ABC, because if I knew what these two were, if I added them up and take them away from 180, that gives me my last one, because angles in a triangle, and being naughty, angles in a triangle add up to 180. And we need a final statement. Therefore, similar, and I'm going to use a bit of a shortcut, angle, i.e. all angles are the same. Right, this word similar is also a bit of a trigger word into thinking about scale factor. Scale factor is big value over the small value. So up here we have got our two triangles that are going to give us our scale factor. So my scale factor here is going to be 40 over 30. It's obviously the same as 4 over 3. We want to work out the value of E to B, which is this little bit here. In order to know that, we're going to have to do A to E, which is this short area here. So I'm going to do 28 divided by 4 over 3. Non-calculator paper, so I'm going to do 28 over 1 times 3 over 4. And I'm going to cross cancel to make my life a little bit easier. Both these numbers are divisible by 4. 7 times 3 is going to give me 21 over 1 times 1 is 1, so it's 21. So now I know that this length here is 21. I need to know this little section here, well that's 21, so 28 minus 21 is 7. Done.